This is a video on how to draw a trend line, a line of best fit, and find the slope. If you want to figure out how to do a scatter plot, then you're going to have to go back to my last video. So this is left over from that video, and it has a trend line on it, so I'm going to get rid of that. Goodbye. And then I'm going to copy and paste this onto a Jamboard. So click the three dots, go down to copy chart, go over to my Jamboard. I'm going to hit Control V, which is paste, and make it bigger. Okay. So in order for us to draw a good line of best fit, first of all, I want it to be a straight line. So in order to do that, I'm going to hit Shift and then click and draw, and that gives me a straight line. And when I make my line of best fit, I want to make sure that there are an equal number of points above and below the line. So if I do something like this, that's not a great line of best fit because there's 2 points on the line and then 1, 2, 3, 4, 5, 6, 7 points below it and none above it. So not that one. Same thing. If I just connect the first and the last, all the other points are above it. So that's not a good line of best fit. So most likely I'm going to have to go through somewhere in the middle. If I go like here, there's 1, 2, 3 above it, 1, 2, 3, 4 below it, and 2 kind of on it. That's pretty good. So there you go. So that's the first part, drawing a good line of best fit. I actually might change this a little bit. Maybe I'll go more like here. Yeah, so there's 4 underneath it, 1, 2, 3, 4 above it. They're all actually pretty close. This was pretty good data that I took from someone a few years ago. The next part is finding the slope of this line. This is a force versus stretch graph. The slope is going to be K. And so what I'll do is I'll take this point right here and the point 0, 0. So to find slope, I'm going to find the change in y, which is how far up you go, right? That's the change in y. And I'm going to divide that by the change in x, which is this. Okay, and so you should be able to go to your data table and figure out exactly what the value is of this point that I circled here. So that's somewhere in between 0.5 and 0.75 for stretch. So I'll go back to my data table. And then between 0.5 and 0.75, we have 0.6, and the average force for that is 6.23. So this right here was 0.6 and then 6.23. So my change in y is going to be, it's going to be that 6.23. So from here up to here is 6.23. And then my change in x from here to here is 0.6. I always use 0, 0 as one of my 2 points. It makes everything easier. Plus, I know it goes like directly through 0, 0. This is missing. It's getting the point. It's not directly through the middle of it, but it's pretty close. So we'll use it. So finally, to get my slope. So some of you guys say y2 over y1, or sorry, y2 minus y1 divided by x2 minus x1. I just keep it simple. And I say change in y over change in x, delta y over delta x. Your k's are always going to be positive. So we've got 6.23 divided by 0.6. And you guys, that's a 0. All right, so then I'm going to pull up my calculator, which I think you guys can see in this video. 6.23 divided by 0.6. 10.383 repeating, so I'm just going to round it to 2 decimals. 10.383 rounds to 10.38. And then the slope should be pretty easy because the change in y was 6.23 newtons. The change in x was 0.6 meters. So that means newtons per meter, which is, of course, K, newtons per meter. And that is how I find that.